Yes. Okay, I'll go first. Welcome all. As you know, this is a workshop for Cluster with Kubernetes. We have our speakers Kinnari and Sharanya for the same. We are a group of passionate programmers from ThoughtWorks, and we organize monthly events like these to encourage knowledge sharing among women. So, yeah, that is what we are doing now as well. And as for my personal introduction, I am Anusha. I work as an app dev in ThoughtWorks, and I have completed 2 years um, of my work recently. I'll pass it on to Kinari.
Sure. Thanks, Anusha. Hello, everyone. A very warm welcome to today's workshop on Cluster with Kubernetes. Thank you very much for joining. It is a weekend morning, so I can understand, but I can see the enthusiasm is very, very high. So I'm really, really impressed. Hoping to have a lot of fun and learning in today's session. So a little bit about me. My name is Kinnari Sutaria. I'm a senior consultant working with ThoughtWorks for more than 2 years now and having overall 4+ years of experience in the industry. I have worked on various technologies throughout my career, and lately my interests have been inclined towards DevOps, I must say. And thus, I've conducted a couple of workshops, such as Docker in a Day. That was my previous workshop. We had it a month back, I think, and wherein we did create a container in a complete, like we did create a complete container in just 2 hours. So that was Docker in a Day workshop, wherein you can get everything about Docker that you want to know to get started. Then I also have conducted a workshop on building serverless solutions using AWS in the past. And today's workshop will be on Cluster with Kubernetes, conducted by myself and Sharanya. Sharanya, would you like to introduce yourself?
Yep. Thanks, Kinnari. Hello, everybody. I'm Sharanya. I am from Coimbatore. I work as a developer with ThoughtWorks. I'm here for about 14 years. And I'm also recently stepping into some of the infrastructure bits of work. So Kubernetes is my latest area of interest. So I learned a little bit of it, and I thought I could share some of my knowledge on how we used it. Let's get started with some of the basics today, and we will see how we will be able to learn a little bit more in the upcoming sessions. Thanks everybody for making time on a Saturday morning. Really appreciate your enthusiasm and efforts to come here. Hopefully there'll be good takeaways for you. Thank you.
Thanks, Sharanya. Shall I quickly share my screen? Yes, Anusha, you were saying.
Sorry, Kinari, I forgot to introduce. So today I'll be facilitating the session along with Maria. I'll let her introduce herself.
Sure.
Hey everyone, I'm Maria and I'm from Kerala. I work as an application developer at ThoughtWorks. So I recently completed 1 year at ThoughtWorks. Yeah, that's pretty much about me. Have a good learning experience, everyone.
Thanks, Maria. Thanks for the quick introduction. I'll quickly share my screen. Let me know when it's up.
Yeah.
Yes, it is.
Okay. So without further ado, let's get started. So basic rules a little bit. Please be on mute when you're not speaking. Feel free to raise your hands when you have any questions, or you can also put your questions and queries on the chat. We'll be continuously monitoring the chats and we'll try to answer all your questions. It'll be great if you would turn on your videos on so we can have the session as interactive as possible and make the most out of it. Otherwise, I'll definitely doze off. Just kidding. So let's get started with today's agenda. First of all, let's look what we're going to learn today in today's session. We'll be starting with why do we need Kubernetes and what can it do? What is Kubernetes? We'll be talking about the features of Kubernetes. Then we'll go through Kubernetes architecture and see how Kubernetes actually works. Then we'll learn about the main components of Kubernetes. And then proceeding that, we'll be going through the concepts of Kubernetes, such as pods, replica sets, deployments, and so on. And also, we'll do a hands-on along with those concepts. So we'll have short assignments for you to get confidence on whatever you have learned throughout the session today. So along with the concepts, we'll be doing hands-on as well. And we'll be giving you short assignments with tweaks as well. So you will also get confidence on what you have learned out of today's session. And I hope that it will be really, really fruitful for you all. So let's deep dive into the ocean of Kubernetes. So, before that, we have a meme over here. I'm a great fan of memes, so I really keep on creating memes. So here you can see that today, whoever has come into this workshop, most of them has this feeling, what on earth is Kubernetes, right? And you're really afraid to ask everyone, okay, what is Kubernetes? Because it's been going on since a long time. And you must be hearing from the infra folks that, okay, it is so easy. It's just a couple of YAML templates that you do, and you have everything up and running. So don't worry, post today's session, you will be also able to tell that Kubernetes is nothing but a couple of YAMLs you have to configure and everything will be up and running. Okay. So yes, let's jump to why do we need Kubernetes and what can it do? So basically, you can we all know that Docker enables us to package applications into containers, that is standardized executable components, combining application source code with the libraries and dependencies required to run that code in any environment, right? So basically all the dependencies and library issues, it's not running on my machine, it's running in your machine. All these issues created a matrix of hell, right? In order to have all of them combined and create an application up and running. So Docker was the solution for this. And we had a workshop on Docker as well. So you can refer the details of Docker in a day workshop on this YouTube link. Everything you require to know about Docker, how it works, its features, and how do you containerize your application from scratch is available over here. Okay, you can go and refer that. So basically now your application is up and running. This is what your application would look like when you host it on Docker, okay? So containers are a good way to bundle and run your applications. But in a production environment, you need to manage the containers that run the applications and ensure that there is no downtime at all, correct? So for example, if a container goes down, another container needs to start. And what if the number of users increases? You need to scale your application, right? And you also need to scale down when the load decreases. So wouldn't it be easier if this behavior is handled by a system? Say, for example, I want a production environment where I want multiple hosts to be running so that I don't have a downtime. What if I want one more service to be running on a particular host, right? So how do I do that? What if I want to scale up? As you can see, I scaled up. Now I have 4 hosts running, right? What if my users are not that much active and I want to scale down? So again, I have only 2 hosts running and out of the 4, 2 are eliminated. So how does all this happen? I cannot keep on monitoring all the time as an infra person, right? When will the application go up? When I have to increase the number of hosts? When I have to decrease the number of hosts? So it's really difficult to do it all manually. So what is the solution for all this? Right? The solution is like, we require a system that manages the connectivity between the containers and automatically scales up and down based on the load that the application is getting, right? This whole process of automatically deploying and managing containers is known as container orchestration. And that is where the orchestration tool comes into picture. That's how the container orchestration tool, Kubernetes, comes to the rescue, I would say. Kubernetes provides you with a framework to run distributed systems resiliently. It takes care of scaling, failover of your application, provides deployment patterns, and many more things, you know. It's not just Kubernetes that is the orchestration tool. There are various orchestration tools like Docker Swarm by Docker, MessOS by Apache, and Kubernetes by Google. Okay. So let's jump on to what Kubernetes is. Before that, if you have any doubts, please let me know, raise your hands or put it on chats. And if you feel that I'm going too fast, going too slow, just let me know that as well. So we can give you a very, very good experience in today's workshop. So what is Kubernetes? This is a logo which everybody must have seen of Kubernetes. So let's talk about what Kubernetes is. Okay. So anyone wants to give it a try? Can you put it on chat? What do you think Kubernetes is instead of seeing on this slide? Whatever your answers are, you can put it on chat. Anybody? Are the chats coming? No. Okay. Okay. No worries. I'll take it a shot and I'll tell you about what Kubernetes is. So basically, Kubernetes is one of the most trending technologies in cloud computing as of today. It is container orchestration technology used to orchestrate the deployment and management of hundreds and thousands of containers in a clustered environment. Believe me, it's hundreds and thousands. You cannot even count that much. You can have it in one. That much can be managed by Kubernetes alone. Kubernetes is supported by various cloud platforms. We have Kubernetes on Azure, we have Kubernetes on GCP, we have Kubernetes on AWS as well, that is EKS. Okay, let's talk about a little bit history about Kubernetes, right? We are always curious why the name Kubernetes, right? Or why is it called K8s, right? So the name Kubernetes originates from Greek, meaning helmsman or pilot, okay? Something, pilot is what? They drive your aircraft, right? You don't have to take care about anything. Everything pilot will be taking care about, right? So that's why the name Kubernetes. K8 is an abbreviation resulting from the counting the 8 letters between the K and the S. Okay, that's why we call it K8. Of course, we require short form for each and everything, right? So that's why we call Kubernetes as K8 as well. What else is the history? Google open sourced the Kubernetes project in 2014. Kubernetes combines over 15 years of Google experience running production workloads at scale. So imagine everybody use Google in our day-to-day lives, right? And we know till what extent we are using Google, correct? Still, Google is able to manage all these production workloads. How? It's because of Kubernetes and other things as well. So, yeah, that's about Kubernetes. Okay, let's go to the key features of Kubernetes.
Kinnari, if I can interrupt you for a second. So Radha here wants you to repeat the need of Kubernetes. If you can summarize.
Sure. Okay, we got questions. I couldn't see the chat. Okay. Can you again tell me the need of Kubernetes? Okay. So Radha, let's go back in the slide. Okay. So see, this is the application that I already have. Okay. So now using Docker, my application is ready, right? But what if this is a single application running on a single host? Okay. What if there is more load to my application? Say there is more load. I want to host more number of instances. So what will I do? I have to scale up, right? So when you have to manually do it, you have to manually create instances and manually do all those things based upon the requirement. So you're scaling up, okay? You're scaling more up when the load is more, right? You have to distribute the load across all the hosts so that no one host goes down, correct? Again, when the load is not much, okay? So you have to pull down 2 hosts so that you are optimizing your cost basically of the environment, be it on any cloud you're running, you are getting billable, right? Because of the instances that you're running. So for that cost optimization, we scale up, scale down, right? Based upon our needs, cost optimization, user needs, no downtime, all these things, right? So if an infrastructure person is manually doing all these things, first of all, it will take a lot of time for doing that, right? Other than that, forget about time. Even if we invest time, it takes a lot of manual efforts, right? Something can go wrong if a person is doing that. But if we have all of this thing configured, how do we configure all these things? Using an orchestration tool, right? So what is this orchestration tool? That is Kubernetes. Kubernetes is one of the orchestration tools available out of so many tools available in the market, right? Some of them are Docker Swarm, other is MES-OS by Apache. And the one today we are going to learn is Kubernetes. So basically, instead of having any manual intervention in all these things and putting it somewhere in form of configuration files and getting things done dynamically in runtime, that is what Kubernetes does. That is what the orchestration tool does. And that is why we need Kubernetes. Was I clear on my answer? Who had asked this, Anusha?
Yes,
Yeah.
it's clear.
Okay, it's clear, right?
Sure.
Thanks for
Kinnari, I think-
confirming.
Kinnari, I think there's a question on how is Kubernetes better than Elastic Beanstalk with the auto scaling group settings, ASG settings, right? So I think the answer to this question is the fact that Kubernetes is a general orchestration tool. It can be used across many different cloud providers, not specifically on the AWS. Right? And it gives flexibility in the way that you can containerize your applications, specify which of those apps need to run together and stuff like that. We'll see more of those concepts. Gayatri, are you clear on this? Or do you have any follow-up questions?
Yeah. So the basic advantage would be no vendor lockdown, right? Uh,
Yeah, that for sure
okay.
is.
And feature-wise, like maybe because I do not completely understand. So feature-wise, what else? Because I mean, one particular solution that I know would be an EBS with an ASD setting where it scales down, where you can configure based on your expectation, the min CPU or, what is the scale up, scale down settings and how you want to scale up, scale down, right? So apart from that, what are the features that Kubernetes provide? Maybe you'll cover that later. That was just my curiosity I'm stating. Thank you.
Sure, we'll cover that. And in the end, if you have more questions, we can still address it. Yeah, cool.
Sure, thanks.
Kinnari, you can continue.
Sure. So we covered what is Kubernetes. I think we were clear on that. Do we have any questions on what is Kubernetes? If yes, we can take a pause and answer those questions. If not, we can proceed further. So we went through the history of Kubernetes. What is Kubernetes? And now we'll talk about the key features. I think, Gayatri, this must answer your questions. What are the key features of Kubernetes? So, folks, be attentive on the key features of Kubernetes because we'll have a little quiz after we complete the key features of Kubernetes. Okay. So, the key features of Kubernetes, the very first thing is planet scale. It is designed in such a way on the same principles that allow Google to run billions of containers a week. Kubernetes can scale without increasing your operations team. So that's why the planet scale feature, which is the very important feature of Kubernetes, it never outgrows. Whether testing locally or running a global enterprise, Kubernetes flexibility grows with you to deliver your application consistently and easily, no matter how complex your need is. Okay. You can run Kubernetes anywhere. Anywhere means anywhere. Kubernetes is open source. It gives you freedom to take advantage of on-premises, hybrid, or public cloud infrastructure as well. So letting you effortlessly move workloads to where it matters to you. Whatever your application, whatever your need is, you can do that based upon the orchestration tool Kubernetes. Okay. Next is automated rollouts and rollbacks. So say, for example, there is some issue in your application. So with Kubernetes, it helps you to automatically roll out and roll back. Okay. It progressively rolls out changes to your application or its configurations while monitoring the application health to ensure it doesn't kill all your instances at the same time. Say, for example, if all your instances go down, your application itself will go down, right? And which we see, right, that how important the application uptime is. We cannot afford to have any application go down. You must have seen whenever the Instagram is down or WhatsApp is down, people start tweeting and everybody freaks out, right? So we don't want that to happen to our application. Okay. So that's why automated rollouts and rollbacks are very, very important. And if something goes wrong, Kubernetes will roll back the change for you. So you can take advantage of growing ecosystem of deployment solutions. Okay. Whenever you want to update, for example, you want to update the underlying application version. So that also is done using this automatic rollout and rollbacks. So you have to be rest assured that your application won't go down at all for any amount of time. Okay. Self-healing. So Kubernetes restarts containers that fail, replaces and reschedules containers when nodes die. Okay, we'll talk about the nodes and the other components in the later part of the session. For now, just understand that it will reschedule or replace whenever any container fails to run. Or if any container dies, it will also self-heal that. Okay. So it performs health checks to see if the containers are as appropriately running as we have specified in the configurations and doesn't advertise them to clients until they are ready to serve. So whenever there is a container coming up or coming down, it won't be seen by the clients. Your users won't be able to see that. That's the very big advantage, right? We don't want our clients to know that we are having a downtime or we are rolling back something or we are rolling out something, right? So that's self-healing. Let's go to next. The other features are horizontal scaling, as you saw in the previous diagrams as well, right? We were doing a horizontal scaling. It was scaling your application up and down with simple, you can use that. You can do that using a simple command, a UI, or automatically based upon CPU usages. right? You just have to put particular configuration files and it will do horizontal scaling up and down, whatever is based upon your load. Okay. We do secrets and configuration management in Kubernetes. You can update, deploy secrets and application configurations without rebuilding your image and without exposing secrets in your stack configuration. So without you don't have to rebuild your image. If you're aware of the concepts of containers, Docker and all, you understand that we create containers out of images, right? So if you want to deploy any updates, update any secrets or any application configuration, you don't have to rebuild your image. That is what Kubernetes gives us an advantage of. Okay. It is designed for extensibility. Add features to your Kubernetes cluster without changing the upstream source code. You can add as many features as you want. You can roll back any features if you want. All of this is available by Kubernetes. Okay. I see Q&A 1. Okay. Is it answered? Okay. Awesome.
Yep.
Thanks. Thanks, Sudhani. Thanks, Sharanya. So let's go further. Okay. Before jumping to the architecture, I want to see I talked about a couple of features, right? I think I talked about 9 to 10 features. So could you put in chats that, okay, what features did you listen to and what features do you remember? So what are the features of Kubernetes, folks? Please post your answer on chat. Okay, we're getting answers. Horizontal scaling, planet scaling, okay. Self-healing, yes. Automatic rollback, yes, yes. Oh, I'm really, really fascinated by today's audience, I must say. It's like we are having a very good audience today. Great, great. We have a lot of, everybody's listening basically, okay. So I'm not just the only one who is awake. Okay, okay, got it. Secrets and config management can be used anywhere. Yes, yes. Really, really nice answers we're getting. Awesome. So should we proceed further? Yes. Okay. Let's proceed further. So now we'll be talking. See, until now we talked about what Kubernetes is, why do we need it, what is Kubernetes, the key features of Kubernetes, and I see that everybody is very, very on page with me on all until here. I hope we'll be in the same side further as well. Let's switch to Kubernetes architecture. Okay. So this is what a Kubernetes architecture looks like. Okay, we have master nodes, we have worker nodes. Don't worry, I'm going to explain each and everything over here. I'm just reading out the components first, and then we'll talk about what each of these components do. Okay, so we have master node that manages, plans, schedules, monitor all the nodes. We have worker nodes that host the application as containers. We have etcd, we have Kube API server, we have Kube controller, we have Kube scheduler, we have kubelet, and last but not the least, we have the kube proxy as well. Folks, this architecture is really, really important in order to you to understand how Kubernetes actually does perform in reality. So please pay attention on this. Let's go. Sorry. Before that, I would want to talk about the architecture. Let's just give me a minute. Yes. So the very first thing we start with is nodes. Okay. So a node is a machine, physical or virtual, on which Kubernetes is installed. First, let's consider a node to be a worker machine only. Okay. Then we'll tell you why the master node and the worker node concepts came in. Let's first talk about a node as a worker machine only. Okay. So let's say a node is a worker machine, and this is where the containers will be launched by Kubernetes. Okay. But what if the node on which our application running fails? Well, obviously, our application goes down, and we do not require that at all, right? You need to have more than one node. Now, there are multiple nodes. So, a cluster is a set of nodes grouped together. When multiple nodes come together, we call it a cluster in a very layman terms. This way, even if one node fails, you have your application still accessible from the other nodes. And moreover, having multiple nodes helps in sharing load as well, right? So now we have the cluster, but who's responsible for managing the cluster? Where is the information about the members of the cluster stored? How are these nodes monitored? what else do we have? What else questions do we have? We have, when a node fails, how do you move the workload of the failed node to another worker node? That's where the master comes in. Okay. These all the questions must be in your mind, right? That how are the nodes monitored? How is the cluster information stored? When the node fails, how does it move to the workload moves to another node? We all have these questions, right? So that's where the master comes in. The master is another node with Kubernetes installed in it and is configured as a master. The master watches over the nodes in the cluster and is responsible for actual orchestration of containers on the worker nodes. So to answer all these questions, we have the solution as master. The master comes as a rescue to all these questions. It will do all the monitoring, or it will do all the planning, managing, and everything. Okay. So when you install Kubernetes on a system, you're actually installing all these components. So we talk about the components that are API server, etcd, kubelet, container runtime, controller, scheduler. All are these components of Kubernetes, and also kubeproxy. How can I forget that? So all of these are the components of Kubernetes. So let's go through components one by one. Before that, do you have any questions on the worker nodes and the master node? Or do you have any questions about the nodes, what it is, or what is a group of nodes cluster? Okay, I don't think. Let's proceed further to the components of Kubernetes. Okay. Yes. So let's start with the API server. Okay. The API server acts as the front end for Kubernetes. The users, the management devices, command line interfaces, all talk to this API server to interact with the Kubernetes cluster. Okay. We need to do some interaction, right? If I want to give some configuration files, I want to give some users, okay, these are the users who should be able to access Kubernetes, everything. Anything, if I want to access the cluster using UI, if I want to access cluster using the CLI, anything, how do I do that? I will be able to do that using the API server. Okay. Next comes the etcd. So etcd key store. The etcd is a distributed, reliable key value store used by Kubernetes to store all the data to manage the cluster. We said, right, how will come to know if this is a master node? How will come to know if this is a worker node? What are the nodes in a particular cluster? Where do we get all this information? So we get all this information from the etcd key store. Okay. This will do all the mappings. What master node has what worker nodes, what worker nodes are supposed to report to what master, everything. All these things are stored in the etcd. Okay. Think of it as at this way. When you have multiple nodes and multiple masters in a cluster, etcd stores all the information, all the nodes in the cluster in a distributed manner. etcd is also responsible for implementing logs within the cluster to ensure there are no conflicts between the masters. So in order to separate as well, if etcd has certain rules that it defines and it maps it in such a key value pair so that nobody is conflicting with each other. Okay. Next comes the scheduler. So the scheduler is responsible for distributing work or containers across multiple nodes. Okay. It looks for newly created containers and assign them to nodes. So whenever we are doing scaling up, scaling down, what workload has to go where, what containers have to create in what nodes, all this will be done by the scheduler. Scheduler will check how much node a particular node is having, how much it can scale up, how much it can scale down. Based upon that, it will give particular containers in a particular node. Okay. Yeah. You can take an example for schedulers, such as when you book a hotel room, right? So hotel has its own rooms, set of rooms. It'll see if whenever you book, it'll check in the back end that, okay, if a particular room is booked or not, if a particular room is vacant or not, right? So then when a particular room is vacant, it'll assign you that room, right? Whenever you want to book a hotel. So in that similar way, the scheduler also checks whenever containers are coming up or coming down, it'll check which node should be assigned with that particular container. Okay. Moving on next to the controller. The controllers are the brain behind the orchestration, I would say. They are responsible for noticing and responding when nodes, containers, or endpoints go down. So basically, they have to be, like, the controllers will be aware about all those things and will check if the nodes are performing well, the containers are performing well, none of it are going down. The controller makes decisions to bring up new containers in such cases. So for example, if some nodes have gone down, and my application has to have like 3 nodes or 4 nodes or whatever I've mentioned in the configuration. So the controller will take care that, okay, now the user, the person who has configured the cluster has mentioned to have 4 nodes and there are only 3 nodes running. The controller will take care that, okay, now again, the 4 nodes should be up and running. Okay. Next comes the container runtime. So the container runtime is the underlying software that is used to run containers. Okay. In our case, it happens to be Docker. So that is what the container runtime takes care about. Next is the kubelet. So kubelet is the agent that runs on each node in the cluster. The agent is responsible for making sure that the containers are running on the nodes as expected. Okay, kubelet takes care of all those things. Finally, we talked about all the components. Just one component remaining was the kube proxy. As you can see in the architecture, we have covered everything on the master side. We have covered everything on the worker nodes. Now just we need to talk about the kube proxy. So kube proxy is like network proxy that runs on each node in your cluster, implementing part of the Kubernetes service concept. So services will be talked by Sharanya in the later part of the session. Just understand that for implementing services, we require the kube proxy. Okay. Kube proxy maintains network rules on your nodes. Whatever network rules have to be made sure about. You have to have network rules, right? For the incoming traffic, for the outgoing traffic, and all those things in order to communicate between the nodes, within the nodes, all those things. So kube proxy is used for that. Kube proxy process handles everything related to services on each node. It ensures the connection to the services, cluster IP and port go to a pod that backs the service. If backed by more than one pod, kube proxy load balances traffic across pods. All this thing is done by the kube proxy.
Hey, Kinnari, there are some instances on chat where they want some more explanation or explain again about scheduler, container, and kubelet. Sorry, scheduler, controller, and kubelet.
Okay, 1 minute. And then go back. Okay, let's go back.
And just a reminder that you can also raise hands when you have a question, because by the time you type in the chat and we see Kinnari has moved a few slides ahead. Yeah.
Okay. So let's talk about the scheduler. So basically, scheduler is responsible for distributing work or containers across multiple nodes. Okay. I gave an example about booking a hotel room. Say I am a user. I want to book a hotel room, right? So consider me as a container. Okay. I'm a container who is coming up. Okay. I'm going to come up. So as I'm the container, I need somewhere to occupy, right? In a hotel room. That's why I'm trying to book a hotel room. So what the scheduler will do is it'll check with each and every room. It'll check if the room is vacant or it is occupied by someone. If it is occupied, it won't assign me that room, right? Because someone is already staying there. So for me to be somewhere, I have to be inside a vacant room. Consider that vacant room as a particular node. So when a container is created, the scheduler will see that where this container, that is myself, can go. So for example, if there is a hotel room with 10 rooms, if 6 rooms are occupied, it'll check with the 4 other rooms and put me in one of those 4 rooms, right? So that is what a scheduler will do. This is a very, very simple analogy that I'm talking about a scheduler. Okay. Coming to the controllers. So what this controller will do is it is the brain behind the orchestration. So they are responsible for noticing and responding when nodes or containers endpoints go down. Okay. Whenever some node or endpoint or anything will go down, that is when the controller will see that, okay, something has gone wrong. What do we do? What decision needs to be taken? So I said, I gave an example over here, right? So there are configuration files that we give, and that's how a cluster comes up. Okay. I think someone has raised hand. Just give me a minute. I'll complete this explanation and then we'll give you can unmute yourself and talk. Okay. So controller basically. So say for example, my application, I have a chat application that is running. Okay. I've containerized the application. I've deployed it in the production environment. Now it's a very popular chat application, which I have built. Okay. Let's keep it that way. Now what is happening is, in the earlier stage, there were 1,000 requests coming at a time. So my 3 nodes were able to handle that easily. But now the workload is increasing. and one of my resource came down. One of the node came down. So who will take care of this? The controller. The controller will keep checking if the nodes are working properly or not. If one of them comes down, what it will do is it'll come to know that, okay, node 1, 2, and 3, node 2 came down. But what I have told the controller, that anytime my application should be running 3 nodes in order to support whatever workload my application gets, right? So now it's the duty of the controller to tell that, okay, now we require a new node and that should be a new node must be spinned up. Okay. We'll show you, for example, when we do a deployment scenario, we'll show you live that, okay, I had given the option of having 3 nodes every time running at 3 pods running anytime. But as one of the pod came down, we'll delete a pod in front of you and we'll show you that automatically another pod will come up. How this will happen? This will happen because of the controllers, because it knows that it has to have the desired state of 3 pods running. But right now the current state went to 2 pods, so it has to have one more node running, right? So that is what a controller will do. And what else do you needed? Each node is
Kubelet.
okay. So now coming to the kubelet.
Just a moment. Sorry, Kinnari. I think Deepthi has some question. Should we just address that?
Okay.
Yeah. So my question was.
Yeah, Deepthi, go on. Deepthi?
Deepthi, you're on mute.
Okay, sorry, I was speaking on mute. So my question is like, what are nodes exactly? Is it a EC2 instance or a VM kind of thing, or what is it?
Nodes are like basically containers that are running, I'd say.
Node can be like any physical machine or a VM that is part of the cluster, right? It can be physical or virtual, but the idea is like the logical host that we're talking about.
Okay. No, when Kinnari said that when a container comes up, it will the scheduler will decide which node it should be assigned to, right? So when we speak about a container, we spin off a container on top of a virtual machine or somewhere, right? So how can you decide after spinning up a container? How can you decide how to assign it?
Yeah.
Before spinning up, only you should decide, right?
Yeah, there's a subtle difference here in the sense, like we only submit configurations to the Kubernetes. That is, we interact with the Kubernetes API server and we specify what is the configuration. For example, I want one container and that container should be of type Nginx or should be of type Redis, whatever, right? We specify that. And then what happens is the next step is the kube scheduler sort of kicks in and it decides, it knows a set of nodes and it also knows the amount of resources and the previous amount of pods, number of pods that are scheduled in the node, etc. So it has a hang of all of those things. Basically, the data is actually stored in the HCD. So based on that, it makes the decision, right? Scheduler makes the decision and then it conveys that decision. And from there on, the scheduling takes place, right? Like the communication goes over and kubelet starts spinning up that particular node, which is decided to start off this container, gets the latest configuration and finally starts spinning up the container. Yeah, like for an analogy's sake, she mentioned that, but the thing is, you're right. You first decide where this pod should be scheduled, in which node, where is my space. Based on that, I get started in that node, right?
Okay, so when you say when you say a node, that means it's like a set. You decide like 2 web servers and one backend server should be running. So everything together is a node. Is it?
No, a node is just a physical machine. You can deploy one front-end server, 3 back-end servers, 2 databases, anything, right? Whatever you want, you can deploy. But what is part of a node, typically we don't decide, right?
Okay.
We decide only for this application, I want N number of front ends, X number of backends, and Z number of databases. That's all we decide. And Kubernetes takes this idea or it sort of orchestrates and figures out things.
Okay.
You see, here you can see, right? We have web applications running, we have backend running. in the next part, you see that, okay, we added one more backend. So all is this done because of the mechanism that we're doing behind. So for now, I think you're getting confused because you haven't seen how it actually works in real, right? When you see the configuration files and all, you'll understand. When you do the hands-on part, no, this will be more clear. How there are nodes, we'll do kubectl get nodes, we'll do get kubectl get pods, we'll describe those pods, all those things. So with the help of that, you'll come to know that, okay, how is this actually running? When you yourself will write those configuration files, you'll understand, okay, this is the pod I'm defining, this is the container that will be running inside it, all those things. Okay.
Oh, okay, sure.
Okay. Yeah. Sharanya answered it very well. Okay. Thanks, Sharanya.
Problem? Is it all clear? Shall we? Okay, there's one more person. Anu?
Can we have multiple containers in a single node?
Yes, it is possible. So the way Kubernetes manages it is not in the form of containers, right? Like though we talk about containers, Kubernetes sorts of wraps containers as pods. So pod is the smallest unit that Kubernetes manages, right? For Kubernetes, it is pod, which in turn contains containers, right? And in a node, there could be more than one pod. Basically, eventually more than one container could be possible.
Okay.
Okay. Kirtana is asking more explanation on kubelet. Sorry, before that, Anu, is it clear or you want to?
Yeah.
Okay. Cool. So kubelet. Kinnari, you want to take this?
Sure, sure. So basically what this kubelet will do is, it is like whatever it runs on each node, okay? It can register your node to the API server using any of the host name or anything. So basically it gives, the kubelet will keep sending all this information to the all the controller or whatever the Kubernetes master node. This kubelet will be sending all those things to the master node, and it'll give the health check and everything. Kubelet basically will send all this information to the master node that, okay, this node is working fine. These are the containers running inside it. All this information is sent by the kubelet. Someone has to be there on the node as well, right? To see how the node is performing. What are the, what is the description of the node and everything. So all this is done by the kubelet.
Yeah. So if there could be hundreds of nodes in a typical Kubernetes cluster, right? Then there should be somebody who is like an agent or like a watcher or like a warden inside each of those nodes, trying to understand or make sense of what is happening and finally report to the Kubernetes master, that is more in particularly the API server. So kubelet sort of understands what's happening in the node with constant checks, and it reports to the API server. Cool.
Yeah.
Yeah, that's clear. Thank you.
Okay. Basically, what this kubelet will do is whatever API server sends commands, right? If we want to create something or whatever is happening. So these instructions will be given at the container runtime to start or stop containers as needed. So all these things the managing of all these things, kubelet will be taking the responsibility. Okay. Okay. Proceeding further. So, yeah. So we are good on the architecture part, I think. And now comes the part that I said that, okay, configuration. How do we do all these configurations? Is it that simple? We saw a meme as well for that, right? That the Kubernetes is just about having YAML templates. So let's go further. How do we configure all this? The answer is using YAMLs. We use YAML files for doing this. Most of you will be aware that what these YAML files are, but still, for those of you who are not aware about the concept of YAML, YAML is a data serialization language that is often used for writing configuration files. Depending on whom you ask, YAML stands for yet another markup language. Okay. YAML files emphasize more on the data and not on the documents. YAML is a popular programming language because it is human readable and easy to understand. You'll come to know about that in a couple of seconds. I'll show you a snippet of a YAML that we already have, and you'll see that even if you're a beginner, even if you're seeing a YAML for the first time, you'll be able to understand what this YAML is doing. Okay. So here is a snippet of a YAML. So basically here you can see we have the API version, we have the kind, we have the metadata, we have the spec, and we have the container details. So you can see over here it's very readable. I don't see any high complex syntaxes written that which a normal person cannot understand. Even if I have not seen YAML any time in my life, I'll easily able to read this file, right? So it mentions the API version as V1. What kind it is a pod. It can be a deployment, it can be a service, it can be a replica set, any of it, right? We'll talk about all this in the later session. So don't worry that, okay, you don't know what is deployment or what is a service. Just understand, we're just trying to show a YAML over here, how it looks, okay? In YAML, the spacing has to be appropriate. Okay, otherwise your YAML won't work. So the space management, you have to take care of that. You have to take care of the colons and all those things, the hyphens and everything. It's a very particular in all those things. Then metadata. I'll mention some metadata about my machine. Okay, I want the name as to be Nginx. I can put some labels over here. So with that labels, those resources will be referred. Okay. Now in the spec, we are mentioning that we want to create containers. What containers we want to create? We want to create a container with the name Nginx. What image should be used in that container? Nginx 1.14.2 should be used. Now, if I am someone who wants to like change the version, I simply have to change the version in the image. That is Nginx. Say I'm going to use the 1.16 image. So I'll just change the version over here. Okay. What ports? Now, in order your Nginx app to run, you have to expose some ports, right? So we'll be mentioning the ports as well. So here the port is mentioned and it is referred as 80. So this is how a YAML looks like. Okay, you don't have to worry. We'll again go through this YAML and we'll be showing you how we're running those YAMLs as well and creating pods and deployments and whatnot. Okay, we are bringing them up, we are bringing them down. We'll show you how the automatically how the pods will be created when we have mentioned that we want 3 pods to be running all the time. So all these things we'll be seeing in the further session. Okay. So we're good on the YAML format, right? I see some chats. Okay. I think Sharanya has answered. Okay. So this is the YAML format. Now, okay. So what a little meme. We talked a lot of serious things now. So what gives people the feeling of power? Money, nah, status, nah, but running your own Kubernetes cluster. So that is what today's motto is, to run your own Kubernetes cluster, and that will definitely give you the feeling of power. Okay. Yeah. That was on a lighter note. And I definitely need a break now. And I think so all of you must be needing, because a lot of things we went through: API servers, controllers, schedulers, HTTP key store, kube proxy, all these things, right? So it's a little heavy. Let's take a break. When we come back from the break, it's 10:55. How long do we want to give a break? Anusha, Sharanya?
15 minutes.
Yeah.
Okay, so let's take a 15 minutes break. You can grab a cup of coffee, freshen up and come back. So post this, it's a very interesting part, I would say, folks, because we'll be creating pods, we'll be creating deployments, we'll be creating services. That is not just me and Sharanya, you also all will be creating this. Okay, you'll be creating all of this. We'll give you tweaks and we'll see who is winning the assignments. And I think we'll have some prizes as well for the assignments. Just kidding. Yeah. Okay. So let's take a break. Come back at 11:10. Okay. And then we'll have a hands-on session. Radha has raised her hand. Yes, Radha.
Yes, just for a clarification, like the cluster contains n number of nodes, and each node contains n number of pods, and each pod contains a single container. Is it like that?
Yeah, typically the pod contains one container, but it is
Yeah,
also
yeah.
possible that the pod can contain more than one container also. So pod is
Okay.
one or more group of containers.
Okay. Thank you.
I guess we won't have much content to discuss in the next section if you ask all these questions upfront. But
Yeah.
good. Yeah, you're with the flow. Nice. Kinnari, I was just thinking maybe we can go to the demo slide. If so if all of you have set up the demo, well and good. If not, please choose one of these options and take some time out the 15 minutes. Okay.
See, you can install Rancher Desktop. If you have Minikube, you can run that as well. We are supporting 2 things in today's workshop. One is the Rancher Desktop and another is the Killer Coda. If you don't have the required environment and you are not comfortable doing any installation or anything, you can simply use the Killer Coda link, go there and you can play around with whatever scenarios you want, whatever we'll be showing today. can be implemented in both, in the Rancher desktop as well and the Killer Coda as well. And if you're using some other cluster, any other cluster management, this thing, you can use that as well. You can use Minikube as well. Okay. So anything as you're comfortable with, you can use. It will work on any of the environments. Okay. And there was a Git. Have you shared the Git link, Sharanya?
Not yet. So
We can tell them to clone it as well. Can you please post it on chat? So we have all the YAMLs
Yes, I-
uploaded on the Git. Sharanya will share a link of the repository. You can just clone it. So you'll have all the YAMLs ready. But the assignments that we'll give, it'll have a little tweak. So you won't be able to use the YAMLs as is. Okay. So get ready for your brainstorming. Okay, let's drop off for a quick break. I'll keep the installation slide as is. I won't stop sharing. So you can use that. Okay, let's come back at 11:10. Bye-bye.
bye. Can you see?
Yes.
Yes.
Sharanya.
Okay, cool. Let's get started. So in this section of the workshop, we are going to look at some of the concepts of Kubernetes, like pods and replica sets, deployments, services, as well as namespaces. Okay. So the general idea in Kubernetes is that we have like one basic concept, and on top of it, an advanced concept, and the next advanced concept sort of builds on top of the other. So we'll see that level of nesting in multiple places, in the way pods, deployments, replica sets, etc. are designed, and in the way services are designed, etc. So this is just a heads up for you. Jumping in. Cool. So the first of the item is pods. So what is a pod? As we sort of discussed a little bit before, pod is nothing but a group of one or more containers. And a pod's containers, like if there are more than one container, the various containers within a pod, they share the network as well as storage resources. And pod is the smallest unit of deployment that Kubernetes manages. It does not directly manage containers. Instead, it manages pods, right? So it's the smallest unit of deployment that Kubernetes manages, and it runs in a single node as per the scheduler, right? Like as per the scheduling decision, it runs inside a single node. So this is a diagrammatic representation where you can see within a node, physical or virtual it may be, we have a pod, which in turn runs a container. So N stands for Nginx. So this runs an Nginx web server, right? Any questions? Cool. Yeah.
No, sorry. I was just saying no questions in chat or raised hands.
Okay, no issues. So let's get to see how these pods are in a physical manner, right? So let's just take a task that we want to deploy a web server, which has to receive incoming requests at the port 80, right? So for this, how do we achieve this in the Kubernetes ecosystem is we define a pod using this sort of a YAML specification. It is called a pod template, right? So let's just name it as nginx.yaml. And the YAML template is given here. A little bit of detail on this is the fact that this API version, kind, metadata, and spec are sort of the mandatory fields that Kubernetes expects in any sort of object YAMLs that it manages, right? Like the various concepts of various Kubernetes objects we are going to see, all of them will have this 4 sections as a mandatory fields inside a YAML file. And they help Kubernetes server understand what we are trying to tell it. So V1 is a version and pod is a type of object that we are trying to create. Metadata contains some additional information or metadata, right? Like name of this pod, and it can also contain labels at this section. And the spec is actually a short form for specification. So it specifies what exactly goes inside this pod. So as we all know, a pod can contain one or more containers. So spec has containers as the first item, and containers is actually an array. So in order to specify the array, this dash in between means that within containers, we have an array list of items, and this is like the first element in the array. The first element is Nginx. Its name is Nginx. The image from which it has to spin this container up is from Nginx version 1.14.2, and the port is 80. Right? Any questions so far? Cool. I have to switch. Let's get to the demo part. Let's see how this Nginx YAML or a pod that we can spin up from this Nginx YAML. Just a moment. Okay, there's a question about API version. Yes, API version is like, yeah, there are multiple versions. Like Kubernetes is like a software that was built, so it has multiple versions, one on top of the other. So some of the examples of values that can fall under API version is apps/v1 and stuff like that. Yeah, I mean, to start with, I think just v1 is good enough. Can there be multiple ports? Yes, that's why port is also Yeah, port is an array. Yeah, port, if you can see, port is an array because multiple ports could be specified. Okay, so let me just switch to the environment. So just to start off with, I have the Kubernetes installed. Sorry, I have the Kubernetes version 1.25.4 installed here, and kubectl. If you had this Rancher desktop installed, it comes as part of it. It is also available in the Killer Coda environment. So kubectl is like a command line tool. It is used to interact with the Kube API server. So other ways of interacting with Kube API server is through API calls. But kubectl is like
Sharanya, I think you need to share the screen.
okay, sorry. Yeah.
Folks, whoever are having any environment issues with regarding the Rancher desktop, you can use the Killer Coda link for now, and then we can look into the installation issues. Okay.
Cool. So hope you can see my screen now. Sorry about that. So here there is an environment that I have spin up where we have this version of Kubernetes 1.25.4, and I have used Rancher desktop. So you just go into your machine and start your terminal, then you'll be able to see this. So kubectl, this tool, right? It's a command line tool. This is used to interact with the Kube API server. Right. So I have cloned the Git repo here. So the Git repo that we had shared earlier, it contains some of the files that will be handy. So whatever we saw in the slide deck, right? I have taken it here. Just a couple of additional fields here, that is under metadata. Apart from name, I also have labels. So labels, this keyword is labels, but then under the labels, you can have any custom key value pair here to identify. It is like your grouping, your application, the way you want to group the pods or containers, pods here. So you give some names to this pod. It's label, and we will see use cases where this label is used, right? Cool. Now let us see how we can create a. So kubectl in turn sort of makes API calls based on the different commands that we use here. So this is the command that we use to create any object that is specified in this YAML. So what this does is, if this YAML specifies a pod, then this creates a pod. This YAML specifies a deployment, then it ends up creating a deployment. So let's just get started with it. So it says pod nginx created. So how do I get to see the pod? Kubectl get pods. Are you able to see my screen clearly?
Yes, Sharanya.
So you can give any custom labels, and I have specified 2 labels here. Tire is front end and app name is my app. So this is just a sample for you. So at this point, let's take a break from my explanations, and I think you folks can switch to your machine and get started with trying to bring up a pod here.
A tweak that you all can do is that whatever version Sharanya is using, you spin up another Nginx version. Basically in the YAML, you can see the Nginx version, right? For the image. So use some other image. Okay. So we're using 1.14.2, right? You can use 1.16.2. That is available, and you must be able to do that.
Yeah. Also, you can put different labels here based on. Yeah, you can say tire is web server, or you can say tire is backend, whatever, right? Like those are different options, but these labels are custom defined. So can we see in chat, like if you're able to do it, please post if you are able to sort of replicate this in your environments.
Good. Deepti and Siju has already done it. Great.
Nice.
Okay, we're
So are
getting-
you able to use this also to see what you have created? Get pods, show labels. Okay.
So once we do any change in the YAML file, we have to kill the pod and recreate it, right?
Yes.
Okay. So you'll be showing how to kill a pod.
Yes.
Okay.
So the first time you're creating, you do it with this command. If you're cloning the repository and if you're editing the YAML before even you, like if you're just editing this Nginx YAML, and then you can just issue this command to create it fresh. Like whatever recent changes are made in this YAML will get reflected in this, right? Now, this just gives a high level view of what is there. And what is this 1/1? Any guesses?
One container is running with this image.
One pod in one node.
Like
We have created one pod and that is one.
Right, one pod, and that is ready and running. Cool. So I'll just quickly get to the delete sections because you were interested. So the command to delete a pod is kubectl delete pod and the name of the pod. This will delete the pod. I'm not interested in deleting the pod because I'm going to build on top of this for the next sort of demo sessions. So I'll stop at this. So if we are all good here, I think we can move on. Okay, there's one command that I would want to let you know before we move on. There is this command called kubectl describe pod, right? Kubectl describe pod and pod name. So this gives more details about the pod. So the get pod was like just showing the number of pods, whether it is ready or not, etc. This gives like the pod labels, the IP allocated to the pod, and what are the number of containers that we can see within the pod, and what is the current status of the pod. Is it ready? Is it initialized ready? Containers are ready, and if the pod is scheduled. Right?
Rania, we have a raised hand.
Yeah.
Yes, Vignesh.
So Sharanya, is it like one like a pod can have only one container?
Not really, Vignesh. A pod can have more than one containers.
Okay.
So that's when we have this. That's when we have this array, right? If I want to specify one more container, it is like I can give name is Redis and images, whatever Redis and some version numbers, whatever is applicable, right? And port and so on and so forth. So this is like the second item or second array element inside these containers, and it can specify the next container. So for now, we just have only one container.
Okay, so in case if I have multiple containers inside a pod, they will already have a network established.
Yes.
Like, okay.
They share the network, so they can communicate to each other using localhost.
Okay.
Cool. So being mindful of the time, I will also move on. So we looked about how to create a pod and how to view the pod that we created and how to sort of look into more details by using the kubectl describe pod name command. Moving on, some more details about the pod. So the pod is typically the more recommended architecture is one container per pod model. So typically, it's like you you sort of package your application in a container, and it is like one pod models your application, one instance of your application. So that's where we get to this one container per pod model, right? So there might be instances, corner cases, or like examples like logging agents that have to be coexisting with a pod. That's when the 2 containers per pod or more containers per pod might be applicable if you're doing modeling some legacy applications. But the typical recommendation is to go with 1 container per pod model. And as you just saw, pod is nothing but a wrapper around a single container or 1 or more containers. And who is responsible for creating and monitoring these pods? It's Kubelet. So Kubelet, which is running on the worker node, it is sort of getting instructions from the Kube API server to create the pod, as well as if anything happens to the pod, it reports back to the Kube API server, right? Yeah, we saw this. Kubernetes manages pods directly rather than managing the containers. And each pod actually models one instance, a single instance of a given application. And how do we scale up? So in order to scale up the application, we run multiple pods, and each pod models one instance. So if we want 4 instances of the application, we have to deploy 4 pods, right? So let's say that our task is now changed to our task is now changed to handle more traffic, right? So how do we create more pods to achieve the horizontal scaling? So it's like we deploy more and more pods here. It is not like we deploy multiple containers within a pod to do the scale up. That is not the way forward in Kubernetes. We just deploy multiple pods. I hope this concept is clear. And there's one question here about pod can be a group of other pods. No, that is not the concept. Pod is just a group of containers. Okay. Any questions here? Is Node a VM? Yes, Node can be a VM. It can be a virtual machine.
Can a node have multiple pods?
Yes, it's possible. So, will a node have multiple pods or not? We don't know. But typically, the scheduler decides if the node has so much resources, right? It has the it can accommodate more than 1 pod based on the resource requirements. It does schedule more than 1 pod to the same node. It's possible.
This diagram really mentions all your queries, if a pod can have 2 containers or not, if a node can have multiple pods or not. You can see this diagram. Here you can see that, we have a cancellation mark on the container. It is not recommended, but you can still have based upon your use case. I've shared a link in chat as well to understand more deep about why we want 1 pod, 1 container, or we can have multiple pods as well. Do refer to that Marantis blog. It's really, really helpful to understand it on a deeper level. Cool. Okay, let's move on. So how do we manage a pod? So we rarely end up creating a pod manually like this or by submitting these configurations, right? So instead, we go to a higher level concept called workloads. So these workload resources are used to manage pods. Some examples of such type of resources are replica sets, deployments, stateful sets, and daemon sets. So we'll be looking at a couple of them here in today's session. Why is it a recommended way to have a container per pod? Yes, if you have during scaling, right? Sorry, I'm switching questions between the chat and the Q&A. So I'll just take Jay's question here. Say a pod is specified is defined to have 2 containers. While scale out, does it scale both the containers? Yes, that's what happens. It scales out both the containers. The pod typically scales all the containers in it, right? And going back to this question of why it's recommended way to have a container per pod. So it's like typically when you come across this, the huge advantage of Kubernetes is the fact that it can scale up, right? And when you have
one application as like a one container. So one application is mapped to one container, and if you just have a pod with one container, and if you want to scale that application, it's like you can simply scale up the pods using one of these higher level concepts, like let's say deployments. Then it is easy for you, right, to just scale them as pods. But if you sort of tie in, it's like a high cohesion within a pod if you put multiple containers within a pod. So if you want to scale up both the application as well as the database, then it is recommended to put probably 2 containers in the pod, right? But we only want to scale the API server and we don't want to scale the database as such, right? Then it's like good to model each of them as separate pods and as single containers within those pods. Is it somewhat clear?
Yes, it is clear, Daksha.
Yes. If the pod is down, all containers will be down. That is also true, right? Like pod is like one single entity. It comes up, it scales as that entity, how many ever number of containers you say within it, and it goes down altogether. Okay, cool. So let's move on to see this next level of concept, which is the replica sets, right? So what are replica sets? It is used to ensure that any given number of pods are running at a specified time, right? So let's say we want to run 4 pods always of the Nginx web server. We always want 4 number of pods or 4 instances of the app running, right? Then we can model them as replica sets. Just that we won't be going into a lot of detail with replica sets, because again, as I told you, right, like in the nested way that Kubernetes is built or the concepts are evolved, there is a more advanced concept which is more relevant to today's architecture of Kubernetes. Like if you're architecting an application with Kubernetes, it is more relevant to use that. So we'll just, as a concept, we'll get to know how it works, what it is, etc. But we won't do hands-on, or we won't go into much detail, right? So these replica sets, they sort of create and delete pod so that the desired number of pods is always met, right? So if you have only 3 pods and the replica sets kicks in, and it sort of creates one more pod to meet the desired number of 4. So how does a replica set look like? Its definition, basically, these are all objects in Kubernetes. It's called an object type. And for that, also we have YAML definitions. And what is a little bit different from what we saw on the pod template or the pod definition is the fact that a replica set additionally has a selector. Right? The selector is to identify what are the pods that it can acquire. So remember the labels we spoke about in the demo section. So those labels are used as like selectors, in which you say there could be hundreds of pods running, but how do you tell this is the group of pod that I want to manage, and they're all very similar and so on and so forth? To that we use the labels section. Okay, and the number of replicas of a pod that has to be maintained, and yeah, of course, it also has a pod template, because in the event that replica set has to create a new pod, just to spin up a pod, it just uses this pod template. So as I already mentioned, deployment is a more higher level concept, which in turn manages replica sets. So we will typically be using deployments instead of directly using replica sets. So just to wrap up with this, here you can see the API version, kind, metadata, and spec, the top 4 level mandatory fields for any Kubernetes object specification in the YAML format. You have all of this here. As somebody asked, there is a change in the API version. It is app/v1. So for each object, there is a particular API version, and we need not end up guessing or digesting this. It's just available on the kubernetes.io documentation. We can just pull it up. So, but just be aware that there are different versions available, and the kind is replica set, and it is case sensitive. And metadata typically contains name as well as labels, or it should contain name and labels. So name is front end, and labels here is a couple of different labels that they have. So focusing on the spec or the specification of the replica set, we have the number of replicas. Basically, it is a number of pods that has to be managed. And the selector is is about the labels, right? Like this is so here this label is for the replica set, which is like a different object. But here this label on under the selector, it mentions the label on the pod. So there could be 10 number of pods, 3 of them with tire as front end and 3 of them with tire as back end, right? So then if this replica set is spun up, then what it does is, if there are already three pods running with the tire label having tire as front end, then it just takes those under it to manage. And then when one of them goes down, then the replica set kicks in to bring them up. So how does it bring them up? This template. It is nothing but the little bit of a replication of the pod template. So from in the pod specification, we saw the metadata and the spec, and it contains one or more containers, right? Like that section is repeated here. And we also see that it is a mandate that the labels that are given within the pod specification or the pod template should match with the selector labels. So this is the logical thing, right? Like if I, as a replica set, if I spin up new pods, then those should have the same labels as the existing labels that are there. So these two should be equal, and it sort of matches the labels for the pod, while this label is for this top level object of the replica set, and it might or might not be the same. It can be different too, but these two have to be the same. Right, and kubectl get replica set is a command, and there's also a short form rs for replica sets. So I won't get into sort of showing you how this works, but then it's the same thing, right? You can just pull up some of this replica set documentation or YAML file from the Kubernetes IO documentation and save it as a replica set.yaml file and just say kubectl create -f. It does it. I'll leave that to you if you're really interested. And just taking a couple of minutes here on the questions. Is there any hierarchy diagram like deployment, replica set, and pods? Yes, there is. I will get to it in a minute. A replica set, okay. Can't we combine replicates and pod YAML file? Yes, we can, and this is it, right? Like replica set is the one which sort of embeds. If you can see, this template section is embedding the pod template, the most important, right? Like apart from API version and kind, the metadata and spec, which used to be for the pod, that thing is repeated here for metadata and spec. So this is basically the pod specification. Once again, about the selector and template. Okay, so Veena, to your question, right? So it can be the fact that in an environment, right, you just spin up a pod. Then you come to the idea or the understanding that, okay, I will not go very far by just manually managing these pods. I should start creating replica sets to manage these pods, right? So you first create pods, then a hypothetical scenario, just imagine this, right? You first create pods, and then you get into creating this replica set. Now, the replica set is saying, I want only 3 replicas. And let's say when you had initially created the pod, you had only created 2 instances of the pod, right? Now, how many replicas is this replica set supposed to create? Right? Yes, it is supposed to create only 1 more replica, because the idea is altogetherly for that type of pod, I just want to create 1 more and totally maintain 3 of that type, right? Like basically that type. How do I mention that type? That is this labels. That's where the significance of labels comes in. So the tire front end is like a label. Like, how do you call me a Sharanya? Likewise, how do you call that name, call that pod, right? You label it. You'd call it as tire front end. So so this replica set object comes up in Kubernetes environment, it will see, okay, are there any pods which are really with this label, right? If there are already 2 pods, what happens is, instead of those 2 pods just lying in the Kubernetes ecosystem and managed by the higher level API scheduler, whatever, right? Instead, what happens is it becomes acquired by the replica set. It sort of comes under the umbrella of the replica set. Now, what happens? I have to create 1 more pod because I want 3, only 2 are already existing. Now, what do? I want to create 1 more. So I use this pod template, right? So how to create one in the worst instance that something goes down, then how do I create one? Then I need that specification, right? So that is here. So, I mean, this is just to cover all the scenarios, like what if I already have a pod, and what if the replica set goes down, comes up, etc. Right? Like it's a very volatile environment. Pod can go down anytime, and anytime they can come back up again, like being spinned up by the Kubernetes controllers, etc. So this, if you see, a lot of this concepts will be like at any time, I should be able to make sense of what is the state now and what is the state that I want. And based on that, I'll be able to position the number of instances, etc. So this label here is when I create the one more new instance, that also should have the same label. So then all of them will be like 3 pods with tier is front end managed by this replica set. Okay, cool. Let's just move on. Yeah, I think somebody asked this diagram of nested levels. Just 2 levels we have seen. One is this replication controller, which is sort of taking or acquiring multiple pods, right? And okay, one more concept here is the fact that these pods can reside across nodes, right? So the way we saw pods, only a pod will be sticking to one node. If it goes down, and it can come up in any other node too. But then a pod is limited to a node. A pod will not be like spanning across nodes, etc. That doesn't make sense, right? So a pod is limited to a node. But then when we come up with this higher level concepts like replica sets, so replication controller is actually an older name for replica sets, right? So you can just assume both mean same, or replica set is the advanced one. So it's like these pods can span across nodes and still manage it as one entity. Like even across nodes, there will be only 3 or 4 instances as specified by the replica sets definition. Yeah.
Sharanya, do you want to take a question? Deepthi has raised hand.
Yeah, sure. Go ahead, Deepthi.
Can you go back to the previous YAML of replica set?
Yeah.
So here, like we are defining that 3 replicas of particular pod should be present, right? So why are we defining the template again? Because pod already has a template of how to create a pod, right?
I mean, it depends, right? It could be that you don't see in our example, we just created a pod, and now coming to the example of replica sets. For example, you are a hands-on and a well-versed Kubernetes architect. You wouldn't go and create a pod. There won't be any pod at all. Like there won't be any pod YAML at all. Instead, this replica set will be, you directly deploy a replica set in the environment, and then it says, oh, there are 0 pods. Now, what do? I have to spin up 3 pods, right? That's the work of replica set, isn't it? So how does it spin up? So it embeds. So it's not like you can link to any other pod. You have to sort of embed it. That's the way it works.
Okay, got it.
Okay. There was another question. How can we check whether a pod is down? Yeah. So I will show it when we get to the deployments. It is a way that you can check. Yeah. kubectl get pods is an option, like Kinnari had said, but then there's also a way, like you can say get replica set. It will show you the number of pods that are available versus number of pods that are not available. Okay, before I move on, I'll just take this question. Gayatri, please go ahead.
Yeah, so is replica set the only way of configuring horizontal scaling? If you do not have a replica set configuration, what happens?
Replica set is a way, and there are more advanced ways. So replica set is not the recommended way. Deployments is the recommended way.
Okay.
Cool. Okay. Getting to deployments. So it's the next advanced concept, right? So a deployment, what does it do? It creates a replica set, which in turn creates pods. Now I think it's very clear for us that how it builds on, right? Like we started off with pods. In order to manage pods, we got replica set, and something more than the replica set, or something better than the replica set is the deployment. So what does the deployment do? Again, it is a Kubernetes object. It has, how do we specify it? It has again a YAML template, and probably the kind will be called a deployment rather than being pod or replica set, etc. And what does it ultimately do? It calls out a desired state. Like where should my cluster, how should my cluster look like, or how should my application look like, right? So a deployment, we typically, like for one application, we manage it using a deployment. And for multiple applications in our architecture, we probably will have 3 or 4 deployments based on the logical grouping of applications like front end, back end, database, etc. Right? We'll have different deployments to manage. So deployment is to manage one type of application, right? So it will tell the desired state, that is how many number of pods there should be, and what is the version there, etc. So going back to the concepts that we saw in the architecture, right? Kinnari helped us understand about the controllers, right? We saw the Kubernetes controllers. So there are multiple controllers under Kubernetes. One such controller is a deployment controller, which actually monitors the deployments that we are submitting to the Kube API server, and it takes the cluster or the deployment within the cluster from a current state or the actual state to the desired state. And this shift does not happen like this. It happens at a controlled rate, at the rate at which it can spin up, acquire resources, make sure that they are all running, and then move on to the next one, and so on and so forth. Okay. So we also saw the fact that the replica set is not a good idea to do replica sets, but rather go for deployments, right? So what are the use cases for which we would step into the realm of deployments, right? So one is when we want pods to get into updated states often, right? Typically, I develop an application. Today, I release one version. After a month, I will release the next version. So that is a typical use case where these pods keep on updating and scale up. Yes, based on the need, I have to scale up an application or a deployment. This can be done using deployments. And some of the additional features that the deployment gives is the fact that it remembers the state, right? What was the state now and what was the state before? So it enables you to roll back to the previous state. Okay. So this is a logical diagram so let's assume that we have an application. It's a Python application in this diagram. Nevertheless, any application which has which is in its current version V1 and it wants to move to the advanced version, let's say the next version V2, then what happens? Deployment helps enabling this shift in or update in the versions, right? And this is a diagram that shows that we have pods as a smallest unit, and then replica set on top of it, and deployment, which in turn manages the replica sets. Okay, cool. So just to understand once again, why is it better to use deployments? One thing is scaling up of pods and performing these upgrades. And how do we perform these upgrades, right? That is called the deployment strategy. So there are 2 strategies here. If you can look at this diagram, this first strategy is called recreate. In the sense, let's say this deployment has 5 pods, right? In this recreate, all of the pods are brought down at the same instant. Then the application goes down. Then there's like a couple of seconds by which the next version is brought up again. So there is a minor slice of time by which the application goes down, right? So this is a recreate strategy. But then there is an advanced strategy called the rolling update. And this rolling update is actually the default strategy that Kubernetes follows. If we don't specify any deployment strategy, it falls back to this as the default, the rolling update as a default strategy. So in this, if there are like 5 versions, as we can see how it happens is the one pod is taken, it is taken down. One pod is selected, it is taken down, and a newer version of that pod comes up. And the next pod is taken, then it is brought down and comes up, etc. So what pod runs what version and how they come up, and eventually they all get updated. It's a rolling update. And the advantage of this strategy is the fact that at any given time, there is some version of the application which is already running. So the end users don't face like an application downtime issue, right? So this is about how we perform the upgrades. And as I mentioned, the rollbacks are also possible because it remembers the previous version. can go back. And there's also an option on paused rollouts. That is, if you have to make 3 or 4 changes and then bring up, so you can pause the rollouts. Like as soon as you edit the deployment YAML, it sort of starts rolling out the changes. So you can do that. You can make a pause on it. You can make all the changes and then you can do the rollouts. Yes. Are all the pods in a node upgraded first before moving to next node? That is not like a given. So, I mean, yeah, in a node, this happens, right? Or at any point in time, there are some nodes which are serving the application. That much is taken care. There is nothing like a node-based specification on this, right? These pods are taken down in an incremental fashion. Yeah. Maybe Kubernetes does something internally, but we are not very much bothered about it, I would say. As long as there is some version of the app which is running and slowly it is getting to the newer version. Does that answer your question, Ayan? Okay, I hope so. Until he answers. Yeah, Gayatri, please ask your question.
Yeah, so I was just curious, like one of the challenges we face in my current job is when you have transactions that are in progress, right? And then when you are doing a deployment, so what would be the best deployment strategy to ensure that we don't have a failed transaction?
Yeah, rolling update is the best way forward. And there is also more configurations here, right? Like how do we sort of configure stickiness of the sessions and stuff like that. So there are much more configurations involved, but at a high level, this is the strategy. I would suggest if you are looking for more advanced options, there are like liveness probes, readiness probes, and many other concepts which ensure that that particular application comes up and it's ready to serve, and Kubernetes takes that into account.
Okay, thank you.
Up to that, when can we use a recreate strategy? When your one version of the app that is already deployed is not at all compatible with the other version that is going to come up. Okay, they're very different. They cannot run together. That's when we think of recreating. That is, we stop everything. There is a downtime, and then everything comes up. That's when you use a recreating strategy. Otherwise, you should always go with the other strategy, rolling update strategy.
So I have a question like first point is managing scaling up of pods, right? Both replica set and deployment, both can scale up pods. Like why deployment means because of the first one I'm just asking.
Yeah, why deployments? The other pointers here are the answers.
Okay.
So we can't do upgrades in replica sets, right? Then that's why we go for deployments.
Yeah, upgrades are sort of manual there. In the sense, I mean, you can do upgrades, but you can't do rolling updates.
Oh,
right?
okay. One by one, we have to do.
You can't do rolling updates, you can't do rollbacks, and you can't do paused rollouts. Yeah, this scaling up, yes, I agree. It's the same concept, but then there are some advantages. Okay, cool. I hope it's clear. Let's just move on. Yeah, so we are getting to the concept of deployment and trying to get hands-on with it. So this is the template for the deployment object specification. So the API version is apps v1, kind is deployment, and metadata has name and labels. And the specification, it's again very similar to the replica set. We have replicas, selectors. The match labels is the same concept. It should match the labels of the pod template. So followed by the pod template here, right? I assume this is sort of pretty straightforward. Now let's switch to creating a deployment. So I have a similar deployment YAML file here. So it runs 3 versions of the pod. It's supposed to run, and it is based on the Nginx version 1.14.2. And yeah, the label for the application is app Nginx, right? Okay, so how do we create it? kubectl create -f, and the name of the file which contains the deployment specification. So it says it's created. Now, how do I know what got created? kubectl get deployment. Now it says 3 out of 3. What does this mean? Any guesses?
The three pod is created and that is in run.
Right. It gets, it has 3 pods specified, or it's supposed to manage 3 pods, and of all of it is ready. Yeah, that's what it means. So the like RS is a short form for a replica set. Deploy is a short form for deployments, right? Now we said this deployment actually creates replica sets, right? RS is a short form for replica sets. Let's get to look at that. kubectl. Are you able to see my screen?
Yes, Sharanya.
Yes.
kubectl get RS, that is get replica sets, and it is giving something like this. So basically, it's an extension of the deployment, name of the deployment, which is Nginx deployment, and some UUID sorts, right? So this is the replica set that is in turn created by the deployment. Now, finally, what is all this for, right? To get to the pods. So now you can see that there are 4 pods. So for this deployment, I asked to create 3 pods or 3 replicas to be maintained. And how do I identify them? They have this Nginx deployment, basically the name of the deployment, as well as the unique ID for the replica set, and some more unique characters to uniquely identify the 3 pods, right? So this is the pod that's been created by the deployment, and it's managed by the deployment. What about this? This was the initial pod that I created. It is not managed by the deployment. I manually created that pod, and it is not taken under this deployment. Any guesses why it is not taken?
Because of the labels.
Yes, thank you for that. Yes, it is because of the labels. If you can see, right, the labels are different. If only this had the same label, then it would have been taken under it as one of the pod. So the labels are different. So this is the label that I specified, and this is something that I think Kubernetes adds on its own to make sure that it is managed by the replica set. So this is an example. Do you want to try this out? If you are done with this, then I have a little bit of an extension exercise for you.
I just have one more question. Let's say if our labels are only same, but inside the container, I'm having a different pod, like one has Nginx, another has something, Alpine, something. Okay. So how the containers will spin up? Like I have given the replica set, everything. You said it based on the names, like app names, it will group. Like if it already has two pods, it will create one pod. Let's say, but inside my configuration is different. Just the label is same, but the configuration is different. What happens?
Yeah, please try it out. Let's see what happens. I mean, all of it is in your hands now, right? You have an environment, you have all of these files. Let's try it out.
Okay.
So right now we are using only one label for matching, right? So can we have multiple in the place?
Yeah, labels are like custom defined. There can be many.
No, not for designing the pod. In the deploys, like must match thing is there, right? There also we can have multiple.
Yeah, you can.
Okay.
If we define the same label to the first one, the Nginx also, so will it be added to this deployment pods?
Yeah, it will be taken under or acquired by this deployment.
Okay.
Okay, assuming we have all tried out, right? Let me just show you a little bit more on the concepts that we spoke about, right? So there's a kubectl rollout status deployment / name of the deployment. So this is a command which will tell you what is the status of this rollout. Basically, this deployment has successfully rolled out. right? And yeah, there is one more command similar to this, what we had seen for the pods, right? There's a command to describe the deployment. It gives more details about the deployment rather than just like one-line responses. It has like a detailed response. Typically, most of the content that we provide in the deployment template, right, Kubernetes object specification, it sort of comes up here. So you can see what are the labels I used for the deployment, what is the selector I have used, how many replicas and what are their statuses, and what is the deployment strategy, rolling update as default, and how many containers it manages. And if I had to create a new pod, then what is it? So on and so forth, right? Like all the details are available. And events is like giving us updates on what's happening inside the cluster. Like is it able to spin up, or if let's say I'm giving the image which is not existing, right? Then it would say I'm unable to spin up because this image, I can't find this image. So I can't spin up the container. And if I cannot successfully spin up a container, then the pod is not up. So the deployment is not successful then. Yeah, it is possible that two different developers could use the same labels. But then typically when we work in an application environment, right, and let's say they are part of the same project, then they would have agreements amongst themselves on what are the labels and stuff like that. Of course, some mistakes could happen, and we can see, right, like when we say rollout, what happens. I mean, when we say that the rollout will not be successful or the number of replicas would be different, from that we will come to know. So it's always good to check, right? After you do the creation, what happens? So create is like just submitting this configuration. Then you have to use these commands like get deployments or describe deployments to understand what is the status.
We had individually created one pod, right? So I added the same label to it and recreated the pod. Now all the 4 pods are having same label, but still one should have been killed, right? That didn't happen. Is there any reason for it?
Okay, can you share your screen?
Yeah, sure. Yeah. So you can see now there are 4 pods running, 3 from the replica set and 1 from individual. So all has the same.
Yeah, but we have this, right? See, you see, the app name is my app and Iris front end.
Okay, so
this means that this is actually outside the deployment. If it was managed by the deployment, it would have a different name. So,
okay, I thought if this particular label is present, then it will be considering.
no, in this case, now what has happened is the fact that that is like a separate pod that is existing, and we have the deployment which is only managing 3 replicas.
Okay,
cool. So let's
I'll
get
try.
one more extension of this. Also being mindful of the time. Yeah. Okay. Yeah. So let's take this new task and let's work it out in our environment on how this happens in our cluster, right? Like let's say the task is to release a newer version of the application. So basically, Nginx image gets upgraded from 1.14 to 1.16.1, and we want to scale up to 4 replicas. Yeah. So any idea how we will approach this?
So maybe since we have not specified which deployment model, it will be doing rolling update, right?
Yeah, of course, that's true. So how do we go ahead and update this?
Change the existing deployment file, change it and
Yeah, there are two options. One is you can change this and give this command kubectl replace -f, and you can give this name of the file, right? So this is one way of doing it. And this is actually the most recommended way because typically we will be checking in these files under source code repositories and we'll be keeping track of our changes. So this sort of changing the YAML template, editing the YAML templates and doing this replace is a more recommended approach. There's also another way as a quick one, right? Edit deploy or deployment, Nginx deployment, right? Here you can go ahead and delete, sorry, edit any of these values that are. So you can see whatever we have specified in our template now, that is part of this specification. So it's basically a copy of the template. Basically, Kubernetes has taken the template that we have given, and of course, it would have added some additional attributes here or fields here. Don't bother about it. It is for Kubernetes internal management stuff, but we can see the values that are that can be modified to affect this change, right? So after that, you just save, and I just did exit without the save, but you can like save and exit. Then we can see what happens.
Sharan, I have a question. Instead of replace, if I do create once more, will it not override the existing deployment?
Oh, so create is only for first time creating.
Okay, can you please show us what will happen if I give, let's say by mistake, the create command again? Will it fail?
Yes, it will fail.
Okay.
Okay. So you want me to show?
Incubes already existed.
So now I have edited the normal file, and yeah, Zanu mentioned. Can you see this error?
Yeah.
So
Thanks.
the thing is to go replace. Okay. Can you see this? What is happening here? Any guesses?
3 of the pods are created, 2 are pending. Rolling update.
Yes. Rolling update. So what happens is this 7F sorts is the previous version of the replica set, and the 6.8F, etc., is the new version of the replica set. So you can see that the new version is pinned up, container is getting created, and slowly one by one they are getting replaced. And the older ones, like the 7F, which is the older one, it's getting terminated, right? And how many number of pods we wanted now? 4. So though at some instant there were been like there have been like multiple number, I think what is this 6, but at the end finally it has become 4, which is the desired number. So this is what we mean, right? Like at a controlled rate, it rolls out the changes. Now, because we made changes to the deployment, let's check what happened. I mean, how we can query Kubernetes. So it says rollout successful. Okay. Rollout history. So it says we have like 2 revisions. Basically, we have updated from one to the other, or we are moving from one revision to the other. Or we can also do describe. I'm just going over some of these commands to help you understand the events, right? Like it's like a log. So 7F is the older one, 6.8 is the newer one. Cool. Okay, so far so good. Any questions? Old is getting terminated, yes, new ones are created. Right. Cool. So you were able to do this in your local?
Yes.
Okay. Shall we move on?
Yeah, I think we have a question from Nitin.
Okay. Nitin?
Hi, Sharanya. So I just have a question. How much time Kubernetes gives for a pod to get terminated? So let us say before getting terminated, pod has some cleanup activities or something. So by default, Kubernetes does Kubernetes provide any specific time, or we need to provide?
I mean, I'm not very sure about what exactly the time that it takes, but there is a time called init for a pod. There is a specific time that's called init containers also. So that is just to set up the necessary environment before the other containers in a pod come up. There's a specific concept called init containers within a pod. I'm not sure if there is anything specific to like termination. I think there's some time I don't know, 5 seconds or 10 seconds, whatever it is, but then it has a way of like knowing if the pod cannot be killed. I think it does force kill, because we also have commands to do force kill. So I'm assuming Kubernetes can use it at the background.
Okay. So the reason why I asked was like if there is something which is already happening, and if we forcefully terminate the pod, so we may lose the data and all, right? So it happened for us sometime. Just wanted to confirm if we can give the timeout there itself. Let us say after 30 seconds only like kill this pod. Then pod has sufficient time to do all the remaining process and it can be killed.
Yeah. So I'm not very sure, Nitin. Maybe you can check on it by further reading. But I know that there is something for the startup. I'm not sure about the close down.
Sure. Thanks.
Cool. Let's move on to the next concept, which is called services. So services is a newer concept where now we talk about the other aspects of a pod. For example, a pod has an IP, right? So the model of Kubernetes is an IP per pod. So every pod gets a unique IP, but these IPs are actually ephemeral in the sense the pod can come up and go down at any time. And the moment that the pod is recreated, its IP changes. So these IP for a pod is not static, it keeps changing. If you recreate the pod, it keeps changing, right? So in order to then how do we interact with the pod, right? Like front end has to talk to backend, and there are like 3 or 4 backend pods, and all of them keep shifting and shuffling, coming up and going down, right? Like how do we interact? So we need something which is like a stable endpoint or a stable IP, which will help us to reach out to that pods or ensure connectivity to those pods. So this concept is called services. So services is nothing but a Kubernetes object that sits on top of pods, and it is like a proxy, right? It forwards the traffic that so basically we communicate to the service, and it forwards the traffic to the set of pods that it again manages, right? So it is to ensure stable network connectivity to applications. Kubernetes has 3 types of services in particular. One is a cluster IP type of service. Another is node port and a load balancer. So here also you can see that these are nested. One is built on top of the other. Let's look at them in detail. So starting off with the cluster IP service. So it's a very basic service in the sense within a cluster alone, you can communicate. Objects running within a cluster alone can make use of this cluster IP sort of service. And it cannot be reached from outside the cluster or external network. right? So then what are the use cases, right? Why is it even present? So if you look at this diagram, there are front-end pods, there are back-end pods, and there are database pods or Redis pods, right? Like backend in the sense backend API microservices or API layer. Front-end is the web layer or the mobile layer, whatever. And backend is Redis, right? So here, as I said, this pod has this IP, but the moment this pod goes down, maybe as part of the deployment, this pod, a new pod will be brought up, but it will have a different IP. It will not have the same IP. So here we have this cluster IP service, which is acting like a proxy, so that when the front end wants to talk to the backend, it simply talks to the backend service object, and this service object forwards traffic requests to the original backend pods. So it becomes the headache or the work of the service object to track where are the pods, what are their IPs, who is going down, who is coming up, etc. Rather than each of these individual pods, they can focus on their application work and just blindly talk to the backend service, which in turn will manage it, right? So here again, this is nothing but a Kubernetes object specified using YAML template. So there is again, API version, kind, metadata, and spec are the 4 mandatory fields. So you can see that the API version is v1, kind is service, metadata, we have the name specified there, and the spec has both selector and ports. So selector is to is like similar concept, right? It selects the pods which have these labels and it sits on front of that pod, or basically whenever when this service receives the traffic, whom to forward to the pods which are having these labels. And these are specifications on the target port is the port on the container on which you have to forward the traffic to, and the port is a service port is actually the port of the service, because it's like a proxy, right? It has to have a port to which it is communicating, I mean from in which it is receiving traffic. Okay, so moving on to the next type of service. So since one builds on top of the other, I thought I'll show you this node port example. We will do this as a hands-on. So moving on to the next type of service, which is a node port. Here, what happens is, what is advanced? So basically, node port builds on top of the cluster IP type of service, but what is extra? There should be something better, right? Is it the fact that it allows external access to the pods? So anybody from the outside world can communicate to pods within a Kubernetes cluster using this node port type of service. And what happens here is, we have these worker nodes, right? Like the nodes which make part of the cluster. So in each of these nodes, there is a specific range, 30,000 to 32,000 and odd. So in this range, a particular port is allocated on the worker node, right? And the service starts listening on that port. So whichever traffic that comes to this service, so this is being publicized to all the clients who wants to communicate to this pod, or rather this service, right? Like service is the one which we will advocate outside or advertise outside, saying you talk to me using this port number or whatnot, right? So when the traffic comes to this port, the node's port, it in turn is actually directed to this service object, which is a node port service, which is existing, and that in turn directs traffic to the pod or the container on the pod, right? And this is the YAML specification. Again, API version, kind, metadata, and spec. Kind is service, and this spec type is node port. So the default service, if you don't specify any type, the default is cluster IP. But here we have to specify it is a node port because we want a different type of a service. And what is mandatory here is the port in which the service has to listen. So target port could also be skipped in that case. So target port is actually, as per this diagram, you can see, no, it is the port on which the application is listening on the container or on the pod, right? So that's the target port. So port and target port, like if target port is skipped, it defaults to the same value. Typically, they are same for ease of understanding. They are typically kept same. Node port, if you don't specify, an automatic port which is free in this range will be allocated by Kubernetes. Right. Just one more section on this. One important fact to note is that on all the worker nodes, there might be like 6 worker nodes. On all the worker nodes, this port is opened, and the communication, even though there is a node which is not running this service or which is not running this pod, right? That port will still have that node, that worker node will have that port open, and any request that comes to it will be forwarded to this, because all these services and pods are like lying inside the cluster. They are like uniform within the cluster. Everybody knows of each other's sorts, right? So even if it does not physically run on that node, it is still forwarded. So it opens a port on all the worker nodes. And in any node, you reach the IP address and this allocated port, you can finally get access to this pod. And yeah, as I mentioned, it builds on top of the cluster IP service, but provides an extra functionality of getting to the outside world. There's a small limitation of using this, right? That is, people have to know the IP address of the node to communicate to this, which is not really nice, right? Like, I won't advertise myself with an IP address. So let's see, that leads to the concept of the next one. Just hold that question, Ayan. I'll get to it. Cool. So let's get to the hands-on portion of this. So going back in the repository, I have something called my service. It is actually a node port service, very similar to the template that we saw there. It has a selector as my app. So do we have any pods which has selector as my app? Yes. App name is my app. We have some pod which is having the label app name is equal to my app. So this service will be on top of this pod. Right? Let's get to how do we deploy this? kubectl create -f my service. So the service is created. What got created? We can say kubectl get service or get service. Sorry, SVC is a shortcut. Yeah, so this is something that is it's a different type. We just saw this type, right? Cluster IP, but this is a Kubernetes service which is created by Kubernetes for its own internal operations. Let's just focus on the next one that we created. So node port in turn builds on top of cluster IP. Basically, it creates a service of cluster IP, but has this additional node port or a higher port that is. So you can see the port that got allocated. So it in turn, it actually has a cluster IP. In addition to it, it has a port, right? Now, how do we know what is happening with this service, right? Has it hooked on to some pods, right? Or so what's really happening under the hoods? So just get to the describe command. So this time we are describing a service, the name of the service. So you can see this. Okay, just a moment. kubectl describe pod nginx. So that was the pod which we saw the name, right? So I will show you. Yes, this has app name is my app. So we told this service to look for this selector. And what is the IP of this pod? Currently, the IP of this pod is 10.42.0.23. And if you look at this, right, like this is the previous command that we did. So if you look at this, the endpoint is 10.42.0.23 and port 80. So this gives, like when you describe, you know what has really happened, like what you intended, did it happen or not? It's a way of confirming that this service is sitting on top of this pod and is hooking up to the current IP of that pod. Yeah. Is it clear? Any questions? Is it boring?
Can we get a thumbs up, folks? Not for the boring part, the other one.
So like when we are sharing, like say a service like node IP, so we'll be sharing it with the IP and port number, or the service name and the port number.
IP and the port. Sorry, IP and the port here. Yeah.
Okay, so in that case, our IPs will get exposed, right, in node port.
Yeah, it's it's not a very good option to use that. So cool. You have led me to, sorry. You have led me to the next thing.
I have one more question. So means we can have multiple clusters inside Kubernetes, right?
Yes.
So if a cluster IP is there, so we wouldn't know which under which node what are the ports available. Let's say you are showing one image, right? Like front end talks to back end and to the database. So how we will know which port which is there and all?
Sorry. This cluster IP is not the IP for the entire cluster. Okay. A cluster is the previous concept that we saw, right? Like Kubernetes cluster. It is actually a group of nodes, physical or virtual nodes. This cluster IP is a very small concept inside Kubernetes cluster. It is a type of a service, like how you have a deployment, like how you have a cluster IP service, and for that service alone, this is the IP.
Oh, okay.
It is not the IP of the entire cluster. That cannot be like one IP, right? Because it is made up of multiple nodes. And maybe you can have the IP for the Kube API server, which is your interaction point, like kubectl talks to the Kube API server. All the interactions, it's a head, it's the front end of the Kubernetes cluster itself. So you can interact to it. But there's no one IP like that. So please don't confuse it with the cluster concept. It is just like a deployment. Cluster IP is a type of service, and for that service you just have an IP.
Okay, got it.
So it is like these IPs are related only to servers and not to any physical or like virtual machines.
Yes, very much, absolutely. These services are like very conceptual elements, right? You cannot even like see physically what they do. I mean, they don't host any image or container or whatnot, right? They are like conceptual objects, but they are just here to solve this problem of getting hold of a pod, because the pod is like very volatile and it has ephemeral IPs, like keeps on disappearing on and off. So in order to get hold of it, you have this concept. Okay, cool.
So Sharanya, we don't have to redeploy the service or rerun the service. Service will automatically adjust if the pod IP changes at the backend.
Yes.
Okay.
Exactly. That is the idea. It will manage. Okay, so moving on to the next type of service, which is a load balancer service. So it's like, this one acts like a load balancer, and we're typically, right, it on a cloud platform, we have a load balancer. It can have like a virtual domain name identified to it. Like it has a virtual IP, and then it also has a port. It's like the typical load balancer that we have, and like this is the sort of detail that we share to somebody when they have to access our application, right? So this load balancer, it actually builds on top of the node port service, but it has it sort of distributes traffic to the different pods that are specified under the selector, right? So you can just think of it like an abstraction, right? Like a node port is like very node specific IP address of one or more nodes. If the cluster has like 5 nodes, you have to specify at least one node's IP address physically. And that's not a nice way of communicating. And again, IP addresses might change if the node goes and comes back up again, etc. So this load balancer, it gives there's a virtual IP and probably a domain name that you can associate with it. And it's the typical load balancer concept, but it is also modeled within Kubernetes, right? This is pretty much what we have on all the, on all the services concept. And yes, it is to Anu's question, it is like the external load balancer. Ingress is a little bit of another concept on top of it, but today we will cover only up to this load balancer. Ingress is sort of the next concept that builds on top of it. There's a minor difference.
Ingress is mainly used for load balancing only, right?
Yeah. Ingress is also used for load balancing. So I will just give you a short snippet on what's there, right? Like for load balancer is like for one type of service, right? Like for front end, you will have a load balancer. For back end, you will have a load balancer. And for probably for database, you'll have a load balancer. Then you have to pay for like 3-4 load balancers. Instead, Ingress is a concept which can like cascade. You know Nginx, which can act as a load balancer, right? Like you can tell if the incoming request or traffic is having this path /app, then directed to this set of applications. And if it is having some other path /pay, then directed to the payment service or something like that. So it's basically a combination or a collection of load balancer that can come in as a single instance or an entity called Ingress. Yeah, it builds on top of load balancer.
So is it like lookup to load balancers? Like the concept of Ingress or different?
It's path routing we have, right? Based on the path, you have to route to the multiple services that we have.
Yeah, so that time also we'll be using, that means load balance, like Ingress sits on top of load balancer.
Yes, it's a collection of load balancer. It's not exactly on top of load balancer. It is like it's a combination or group of load balancers can be designed as one Ingress.
Oh, okay.
Okay, cool. Let's move on to the final concept. But it is not the least of the concepts. It's actually one of the most important concepts. So it's called namespaces, right? So namespace is, I'm sure most of you would be very familiar with this concept. It is just the way we can scope resources. Resources in the sense it could be pods, deployments, services, etc. The way we group a set of resources and keep it separate. Isolating a group of resources is the concept of namespaces. So within a namespace, these resources have to be unique, but across the namespaces, there can still be duplications. So when you're accessing a resource, it is always like, I want a pod named Nginx, but then under which namespace, right? So there was one question about what if the labels collide, etc. So typically, if the developers are working in one environment, but they are like not talking to each other more frequently, then it means they will be sort of namespaced. They will be put under different namespaces. So they will be given permissions to act only within a namespace. Like if I'm Sharanya and you are Anu, I can work only under the namespace called dev Sharanya, and Anu can work within dev Anu, right? So if I create a label and whatnot, right, all of it is like valid only within my namespace. It's like my umbrella under which I can operate, and I cannot see what Anu has or collide with her labels, etc., because I don't have permissions to work under that. So that's the way you sort of demarcate, right? Avoid collisions, etc. So if you don't specify anything, like so far we have been getting along in the cluster, but we didn't do anything on namespaces, right? So if you don't specify anything, then it means that the resource gets into the default namespace. So the space that you specify a namespace is like under metadata. You had names and you had labels. You can also have namespace is a valid Kubernetes field under metadata, in which you can specify under which namespace this resource is supposed to be created. Right? Yeah, as I mentioned, it is to divide the cluster resources between multiple users, and also another concept of limiting quotas, right? Like how much storage you can use, or how much storage does this application can use, etc. So if I create a namespace called front-end apps, and if I specify a certain amount of storage resources for it, then that much it can use. Then otherwise it will start creating alerts and failing, saying I don't have, because we want to sort of separate or divide resources across the multiple other, like say backend apps or databases or whatnot inside the environment. So and one more concept is the fact that namespace scoping is available only for certain resources. Like typically the ones that we saw, deployment services, etc., are namespaced. Basically, they can reside within a namespace. But there are certain other resources which are cluster-wide resources, right? They cannot be namespaced. For example, a node is a cluster-wide resource. You cannot say this node belongs to this namespace. No, that is not possible. A cluster is a node is a cluster-wide resource. Likewise, persistent volumes and storage classes. We didn't touch upon those concepts, but as you can see, these are about related to storage. So these are cluster-wide resources, and typically these cluster-wide resources operate at a high level. They will be shared across multiple namespaces. Like resources belonging to different namespaces will be under a single node. It's possible, right?
So, so you mean to say only pods and services will come under namespace?
Yeah, for the concepts that we saw, pods, deployment services, etc., are namespace-based resources.
So Sharanya, actually, just to reaffirm my understanding on this, if I have understood it correctly or not, that if I divide my resources using this namespace, and then if I have pods with the same label running in different namespaces, and if I apply a replication set, then basically it is not going to mix up with multiple pods taking from multiple namespaces. It will act upon only pods belonging to one namespace.
Yes, replica set is under that namespace.
So that kind of risk that we have been talking about regarding multiple teams by mistake using the same labels will not be a problem anymore.
Yeah. If you ask that question, yes, then the answer to that is yes. We can use, like, avoid stepping on each other, avoid this mistakenly using somebody else's labels, etc., by working under namespaces.
And also one more thing, if I've understood it correctly, one node can hold resources belonging to multiple namespaces. That means one node can be shared across multiple namespaces.
Yes, because it's a cluster wide. So there's a cluster is like the bigger umbrella, and there are like smaller. So it's like cluster is like one apartment, right? And each node is like one house within an apartment. So and then we have like family members residing in one house, and so on and so forth, right? So it's like yeah, of course, we all belong to the same apartment, but then we have this namespace or our door numbers associated with that. So namespace is like that.
Here probably it's a little more fluid. One namespace can also flow into another node. I mean, one namespace can have resources scattered across multiple nodes.
Yes, true.
Okay.
True.
Thanks.
No problem. So we saw that when we sort of did not specify any namespace, so what happens is it goes under the default namespace. So all that we have been creating so far has been under the default namespace. So let's just take an example of something else, right? Like kube system. It's another namespace which is created by Kubernetes to do its management. So here we can see there are a set of pods which are running like core DNS, and there are other traffic services and metric server, etc. So these are all managed by Kubernetes, and they reside within the kube system namespace, and they are rightly put under it so that when we say delete all pods, right, then this won't get affected unless we specify the namespace as kube system, right? So do you all want to create a namespace that are on your name and try out this concept of namespace? You can check out the Kubernetes IO documentation on how to create a namespace. And maybe a couple of you can do a screen share to show what are the namespaces that you had created. Does anybody want to share their screen and show what are the what namespace you got to create?
Why is everybody silent? It's okay. Even if you're not able to create, you can at least give it a chance, you know. We are here to guide you. We can tell you. We can help you around. You can just share your screen and we can do it together as well.
Yeah.
Don't worry.
Can I share my screen?
Yeah, sure. Go ahead. I think we can stop the recording.
Yeah.
So I was just also we have the DevOps team who come up with a Terraform script that does a bunch of things that us devs are not aware of. So I understand the YAML. I'm trying to understand how the Terraform script would fit into this picture where we are building a framework for our deployment pipeline.
Right.
Yeah, I can take it. Yeah. So basically, the way we created YAML for this, right? So Terraform, basically we write scripts in Terraform wherein we'll have particular syntax for creating a cluster. We'll have a particular syntax for creating an replica sets, deployments and all those things. When you run that particular Terraform script, all of that comes up. It's like that. So this is you're doing manually. You're running the kubectl create command, right? You're running the kubectl edit command and all those things. There, all of this happens automatically using the Terraform script. Okay. So that's how Terraform comes into picture. So we haven't covered anything about Terraform here, but surely we can plan something for creating a cluster on EKS or something like that in future.
Okay, thank you so much. Helps.
Yeah. So one question is like, what is this Helm chart is all about? I think I frequently get like peers talking about it. So is it same like kubectl or it's something different?
Yeah, a Helm chart is not like it's not similar to kubectl. It is like if you have these packages to these packages and like how do you deploy something to the Kubernetes environment, right? Like let's say you want something on Nginx, then you can just use Helm to do that. It's like a package manager for Kubernetes.
Oh, okay.
Yeah, there's the question about daemon set. Okay, so daemon set is like, daemons, right? That is these sort of background processes that are being run. Again, use cases like typically like logging or monitoring use cases that we want some applications to be run as a daemon, then you can configure them as a daemon set, right? So that whenever a new node comes up in the Kubernetes cluster, let's say a new node joins in the cluster, then this daemon set, when you have declared this daemon set, it makes sure that that particular application comes up as a daemon process in that node. Veena, does that answer your question? Okay. Okay. Could you please share how developers can debug the pods and any developer tools for the same? So debugging pods typically have these commands that we showed you about describe and get a particular resource. That is pretty much how we manage. I don't know, there could be some IDEs I have not used. Kinnari, you are aware of some of them. Like how do you manage pods or troubleshoot pods?
Basically, like ideally, whenever I am working with Kubernetes, we usually refer to the logs of the pods and whatever resources we have created. So logs is what we refer for now. Yeah. There are other UIs as well wherein you can like redirect those logs and you can watch it. For example, if you've created a cluster on AWS, CloudWatch can help you watch those logs. But I'm not aware about any developer tools yet.
Okay. Can we have only one kind, like service or pod for YAML? Okay. There can be like a master YAML which will specify multiple resources also, but I mean it's a possibility. I have not used that though. We typically create singular YAMLs for ease of management.
So you have created pods and deployments right now, right? So in order to check the logs, just do kubectl logs and the pod name, you'll get the logs for that. So if whenever pod is doing any activities, you can check the logs over there. If the application is running, you can check the logs in that particular, you can just add a -f and watch, and you can completely keep watching those logs when you're running the application. That's how you can debug at least.
Yep.
It's 12:54. Folks, I again request you all to submit your feedbacks. I can share the feedback link again. So we can get your feedback and really work upon that for the future upcoming sessions. I've shared the link again. Please provide your valuable feedback.